Deep beneath our feet, locked within layers of shale rock, lie vast reserves of natural gas. This valuable energy source, once thought inaccessible, is now within reach thanks to a technology known as hydraulic fracturing, or fracking. This process has ignited a revolution transforming the energy landscape and sparking intense debate across the globe. Fracking involves injecting a high-pressure mixture of water, sand, and chemicals deep underground to fracture shale formations and release the trapped natural gas. This technological marvel has opened up new avenues for energy production, reducing our reliance on foreign oil and creating thousands of jobs. However, the environmental implications of fracking are a subject of much contention. Concerns about water contamination, air pollution, and induced earthquakes have fueled opposition to the practice. As we delve deeper into the world of fracking, we must carefully weigh its benefits against its potential risks to make informed decisions about its role in our energy future.
Fracking is a complex process that involves several stages. First, a well is drilled vertically into the earth, often to depths of thousands of feet, until it reaches the shale formation containing natural gas. Then, the well is turned horizontally, extending laterally through the shale layer for thousands of feet. This horizontal drilling technique is crucial for maximizing the surface area exposed to the fracturing fluid. Next, a mixture of water, sand, and chemicals is pumped down the well at extremely high pressure. This pressurized fluid creates fissures or fractures in the shale rock, allowing the trapped natural gas to escape. The sand acts as a proppant, keeping the fractures open so the gas can flow freely up the well. Once the fracturing process is complete, the well begins producing natural gas, which is then transported via pipelines to processing plants. This extracted gas can then be used for electricity generation, heating, and various industrial processes.
The United States, once heavily reliant on foreign oil imports, has experienced a dramatic shift towards energy independence, thanks in large part to the shale gas boom unleashed by fracking. The abundance of natural gas unlocked by this technology has reduced our dependence on energy imports, enhancing national security and shielding us from the volatility of global energy markets. This newfound energy independence has far-reaching implications for our economy, national security, and geopolitical standing. It allows us to chart our own energy course, free from the constraints of relying on other nations for our energy needs. This energy security translates into greater economic stability, as we are less vulnerable to price shocks and supply disruptions in the global oil market. Fracking has played a pivotal role in this energy transformation, positioning the United States as a leading producer of natural gas on the world stage. Section 5. A cleaner alternative: natural gas versus coal. Natural gas stands out as a cleaner burning alternative to coal, emitting fewer greenhouse gases and pollutants. It's seen as a bridge fuel to a cleaner energy future, providing less carbon-intensive energy while we develop renewables. The shift from coal to natural gas has improved air quality and public health. Natural gas emits far less sulfur dioxide, nitrogen oxides, and particulate matter than coal.
Section 6. Environmental concerns, water contamination and wastewater management. Despite its economic and energy security benefits, fracking has drawn significant criticism and concern over its potential environmental impacts, particularly its effects on water resources. One of the most pressing concerns is the risk of water contamination from fracking fluids, the mixture of water, sand, and chemicals injected into the ground during the fracking process. These fluids contain a cocktail of chemicals, some of which are known carcinogens and endocrine disruptors. If these chemicals were to leach into groundwater aquifers, they could contaminate drinking water sources, posing serious risks to human health and ecosystems. The sheer volume of water used in fracking operations is another concern, as it can strain water resources, particularly in arid regions already facing water scarcity. Ensuring the integrity of well casings and the proper handling and disposal of fracking wastewater are crucial to mitigating the risks of water contamination.
Section 7. Air pollution and seismic activity. Assessing the risks. Beyond water contamination, fracking operations also raise concerns about air quality and seismic activity. The process of drilling, fracturing, and producing natural gas releases air pollutants, including methane, volatile organic compounds, and hazardous air pollutants. These air pollutants contribute to ground-level ozone, smog, and respiratory problems, impacting human health and the environment. Furthermore, there is growing evidence linking fracking to an increased risk of induced earthquakes. The injection of large volumes of fluid deep underground can alter subsurface pressures and stresses, potentially triggering earthquakes along fault lines. While most of these induced earthquakes are relatively small, some have been large enough to cause damage to infrastructure and raise concerns about the potential for more significant seismic events. More research is needed to fully understand the link between fracking and induced seismicity, and to develop strategies for mitigating these risks.
The great debate: fracking pros and cons. Fracking ignites debate, balancing economic benefits and energy security against environmental and health risks. Proponents highlight energy independence, job creation, and economic growth. They argue it's a cleaner alternative to coal. Opponents cite water contamination, air pollution, and induced earthquakes. They call for a shift towards renewable energy. A balanced approach is crucial. Section 9. The future of fracking, a balancing act. The future of fracking hangs in the balance caught between meeting energy needs and protecting our planet. We must develop robust regulations and advanced technologies to minimize the environmental footprint. This includes stricter well construction standards and comprehensive groundwater monitoring. Investing in renewable energy and efficiency measures is crucial to reduce reliance on fossil fuels. Fracking can play a role in our energy mix, but not at the expense of long-term sustainability. The challenge is balancing economic benefits with environmental and public health. The future of fracking depends on innovation, regulation, and transitioning to a sustainable energy future.